We have all the basic rules for proofs in SL, and that's enough to prove every valid argument. In this video, we'll introduce more rules that aren't strictly necessary, but which make our lives easier when we're doing proofs. Remember that our proof system has 11 basic rules. There's a reiteration rule, and then there's an introduction and an elimination rule for each connective. Suppose we have this problem. Recall the turnstile symbol says a proof is possible. So what this says is that if we take C arrow D and D arrow E as premises, we can give a proof of C arrow E. We set up the proof in the usual way. We put the premises on the first lines, and then we draw a horizontal line underneath that. What we want is C arrow E, and that means it needs to be the last line of the proof. A natural idea is to plan to get it by arrow introduction. Because C arrow E is a conditional sentence, we could use conditional introduction to get it. That's a rule that requires a subproof. So if we want to use arrow introduction at the end, we have to start a subproof in which we assume the antecedent, the thing on the left-hand side, and we want, in the subproof, we need to end with the consequent, the thing on the right-hand side. So on line 3, we start a subproof, assume C, and we want E in the subproof. Here I've filled out the rest of the proof. After starting the subproof on line 3, we can get D by conditional elimination on lines 1 and 3. Then on line 5, we can get E by conditional elimination again on line 2 and 4. Then we can end the subproof, go back to the main proof, and on line 6, we get C arrow E by conditional introduction 3 through 5. Feel free to pause the video at this point and take a moment to think how the rules apply in this proof. If you were doing the proof yourself, though, you might have noticed this rule on the back of the reference sheet. There's this hypothetical syllogism rule, HS, that does just what we needed to do in the previous proof. With the hypothetical syllogism rule, you could have done the proof in one step. You write down the two premises, and then you take C arrow D and D arrow E. You get C arrow E by hypothetical syllogism, 1 and 2. The important point is that hypothetical syllogism is a derived rule. Adding it to our proof system doesn't make any new proofs possible. Any proof that can be done using a derived rule can be done using just the basic rules. It would just take a bit longer. The proof we gave earlier shows that hypothetical syllogism is a derived rule. We showed that we could do the same inference, but without appealing to hypothetical syllogism. But now that we've done that proof, you can help yourself to hypothetical syllogism whenever you want. If you're doing a proof and you see that that step would be helpful, you can do it in one step and cite hypothetical syllogism. Here's another derived rule, modus tollens, which we abbreviate MT. This is another one of those that has a classical Latin name. So if you have a conditional, like A arrow B, and the negation of its consequent, not B, then you can write down the negation of its antecedent, not A. That's what modus tollens lets you do. Suppose we have this problem. Given the two premises, S and T arrow H and not H, prove not S and T. If you notice that this follows the modus tollens pattern, it's a one-line proof. If you didn't notice modus tollens, though, you might think about the proof differently. You could look at what needs to be the last line of the proof, not S and T. Notice that it's a negation, and so think about using negation introduction. Negation introduction is one of those rules that requires a subproof. So we start a subproof on line 3. Assume S and T. And we want to end that subproof with an explicit contradiction. some sentence followed by the negation of that very same sentence. This often requires some trial and error. We derive consequences and see what contradiction we can get. Here's one of them. On line 4, we can get H from line 1 and 3 by arrow elimination. And we already have not H, so we can repeat it. We had not H on line 2. We reiterate it on line 5 using the R rule, so R on line 2. That gives us our explicit contradiction. Lines 4 and 5 are a sentence, H, followed by the negation of that very same sentence, H, but with a negation in front of it. That's what it takes for the reductio subproof, the negation introduction subproof. So we end the subproof, and on line 6, we introduce the negation to get not S and T by negation introduction 3 through 5. Here are the two proofs we just did. On the upper left is the proof using modus tollens, and on the lower right is the proof using just the basic rules. But since both of them start from the given sentences and apply rules of the proof system to get to the stated goal sentence, they're both right answers. It's just that the one using modus tollens is shorter. There's also a special kind of derived rule called a replacement rule. Replacement rules are derived rules that work in both directions. The replacement rules are listed on the second page of the reference sheet. Here's the complete list. For example, the double negation rule, abbreviated DN, says that if you have a sentence with two negation symbols next to each other, you can rewrite the sentence without them. But it also goes in the other direction. Given any sentence, you can add two negation symbols if that's what you want to do. In an earlier video, we worked out this proof. This was effectively a demonstration that double negation, at least in one direction, is a derived rule. But since we've added double negation to our proof system, we could use that instead, and the proof would be a lot shorter. Now that we've added the derived rules and the replacement rules, feel free to use them. The conceptual point is that they aren't actually adding any new provable claims to the proof system. They're just giving us shortcuts for moves that come up often in proofs. That means when you're doing proofs, you should consider using derived rules. They can save time and make your job easier. But it also means, now that we've added the derived rules, that there are different ways to do any given proof. Constructing proofs isn't about doing the shortest proof or the most clever one. What matters is that you can figure out a way to get from the premises to the conclusion. Depending on which rules you use, your proof might not look the same as mine or as someone else's. And that's fine.